Hello student, we learn about the exercise of the chapter electrostatics. A charge, question number 2, first question is asked in exercise. A charge Q is moved from a point A to above a dipole of a dipole moment B to a point B below the dipole. Consider dipole means positive, two equal and opposite charges separated by a finite distance to form electric dipole. Above the dipole and below the dipole. A point is situated above the dipole and B point is situated below the dipole. Therefore, in equatorial plane, equatorial means a line passing through that center of that dipole but perpendicular to the axis of the dipole is known as equatorial line. Without acceleration, find the work done in this process. Find the work done. But the potential acceleration work is done. Therefore, W is equal to Q into V. Means W is equal to, where the electric potential V is equal to W upon Q. W upon Q means the electric potential is defined as the amount of work is done to bring about a unit positive place charge from infinity to a given present location. Therefore, V is equal to W upon Q means W is equal to V into Q. Therefore, W is equal to work done. W is equal to, when the charge is moved from point A to point B, A to point other clockwise direction or anti-clockwise direction. Therefore, the work done is V is equal to VA minus VB. VA minus VB into Q. VA minus VB is equal to Q. Therefore, VA minus VB, the electric potential on the surface of that electric dipole, VA minus VB is equal to 0. VA minus VB, potential is 0, equipotential surfaces. Therefore, VA minus VB is equal to 0 into Q. Therefore, 0 into Q is 0. Therefore, work is done. Find the work done in this process. Work is 0. Second problem. If the difference between radii of two spheres, consider two spheres, one is small sphere and another is big sphere. First, the small sphere its radius is r1 and another sphere having the radius r2. Of a spherical capacitor is increased, state whether the capacitance will increase or decrease. Capacitance increase or decrease. But by definition of capacitance, C1 is equal to C is equal to 4 pi epsilon 0 R1 R2 upon R2 minus R1. By that formula, C is equal to 4 pi epsilon 0 in bracket 1 upon R1 minus 1 upon R2, but multiply by Q. Therefore, C is equal to that factor, C is equal to 4 pi epsilon 0 means R2 minus R1 upon R1 R2. Hence, multiply that factor means R1 R2 upon R2 minus R1. If R2 minus R1 is increased, capacitance is decreased. Means C is inversely proportional to 1 upon R2 minus R1. The proportion of C, capacitance and radius of that sphere, C is inversely proportional to R2 minus R1. Means R2 minus R1 will when increases, at that time capacitance is decreases. Then calculate the potential on or a small sphere, its potential is V1. V1 plate A, plate 1. V1 be the potential on the small sphere or a small spherical plate. V1 is equal to C is equal to Q upon V. Therefore, C is equal to Q upon V means V is equal to 1 upon 4 pi epsilon 0 in bracket Q upon for small sphere its radius is R1 minus Q upon R2. Therefore, 1 upon 4 pi epsilon 0, Q is common, and 1 upon R1 minus 1 upon R2. Therefore, V1 potential is calculated. V1 is equal to 1 upon 4 pi epsilon 0 means Q upon 4 pi epsilon 0 in bracket R1 R2 minus R1 upon R1 R2 upon R1 R2. That is the potential. But capacitance C is equal to Q upon V. Therefore, Q upon substitute the value of V 4 pi Q upon 4 pi epsilon 0 in bracket R2 minus R1 upon R1. Hence, capacitance C is equal to Q get cancelled. Therefore, 1 upon 4 pi epsilon 0 in bracket R2 minus R1 upon R1 means C is equal to 1 upon 4 pi epsilon 0 R1 R2 upon R1 minus R2. This is the value of capacitance. Capacitance C is equal to 4 pi epsilon 0 R1 R2 upon R1 minus R2. Hence, the capacitance on plate, so potential on the plate, V2 is the potential on plate 2. But that potential is Q upon R1. That distance is Q upon R1 minus Q upon Q on the second plate means R2 distance. Therefore, Q up in bracket Q upon 4 pi epsilon 0 in bracket 1 upon R2 minus 1 upon R2. 1 upon R2 minus 1 upon R2 is 0. Therefore, V2 potential is 0. V2 potential is 0. Therefore, capacitance of the capacitor, if the radius R1 minus R2, its radius R1 minus R2 factor depends on R1 minus R2 factor. R1 upon R2 increases, at that time capacitance is decreases. When R2 minus R1 increases, then capacitance will be decreases. Must take whether the capacitance will increase or decrease. If R2 minus R1 increases, capacitance decreases, and when R2 minus R1 decreases,